Now we talk about solving exponential equations. In this unit, we will solve exponential equations and logarithm equations in this section. So first we start with exponential equations. The steps to solving exponential equations are given here. First thing we want to do is to write the equation with the term containing the exponent by itself on one side. So that means we want to isolate the exponent part. Okay, so 10 to the 4t is the part that has the exponential term in it. So this needs to be by itself. So if this is how the equation starts out, we need to get this on one side by itself, and it is. Now we need to divide by that 150. So when we divide both sides by that 150, we end up here with 20. Okay, the 30,000 divided by 120, 150 is 20. So we have 20 equals 10 to the 4t power, because the 150s here cancel. And then we've gotten it where our exponential term is by itself. We can't really do anything else to this. So now we want to undo the exponential part. Well, remember the inverse of an exponential equation is a logarithm equation. So now we need to take the log on both sides to undo the exponential. Now, the log that you take depends on what you're given. Here we have a base of 10. So we want to take a log base 10. If the base is 10, use your common log, log base 10. If the base is e, use your natural log. So that would give us, taking the log on both sides here, the log of 20 equals to the log of 10 to the 4t power. Now here we have to use our properties of logarithms to undo what we have here. Okay, here our log of 10 to the 4t power. We can use our log rule to take this 4t out in front. And when we take it out in front, we end up with log of 20 equals 4t times the log of 10. Now at this point, remember t is what we're solving for. The log of 10 is just 1. So we can simplify this equation to just 20 equals 4t. Or if this is not just a 1, we could divide both sides by log of 10. And we'll see that in some equations in a minute. Okay. Now, once we do that, the only thing we have to do is to divide by 4. And the log of 20 divided by 4 will give us our value of t that we want. And be sure when you put that in the calculator that you use your parentheses correctly. So now let's look at an example of how we're going to solve this. Okay. Let me come down, let me slide down to the next problem here. This is another one of our interest problems. Suppose we have $2,500 invested in an account earning 6% annual interest, compounded continuously. How long will it be? How long will it take for the amount to double? So we're starting out with $2,500. We're going to deposit it, and we want to know how long it's going to take for it to become $5,000. So our continuously compounded interest formula is A equals P times e to the RT. We know our principal is $2,500. We know the amount we want it to grow to is 5,000, and we know the interest rate is 6%. So that would give us the equation 5,000 equals 2,500 times e to the 0.06t power. Now, isolate the exponential term. So get this exponent part by itself. It is on one side by itself, but we've got this 2,500 in front of it. So now we've got to divide by its coefficient. Divide by that 2,500. So 5,000 divided by 2,500 is, of course, just 2. So that gives us 2 equals e to the 0.06t power. Now we want to undo the e to a power. So to undo e to a power, we've got to take the log on both sides. Since our base is e, we're going to take the natural log on both sides. So we'll have the natural log of 2 equals the natural log of e to a power. So natural log of 2 equals natural log of e to a power. Natural log of e kind of cancels each other out, and that just gives us the 0.06t. So then we need to solve for t, so we'll just divide by 0.06. Now be sure in your calculator, let me put this in here. Be sure in your calculator that when you do natural log of 2, you close the parentheses at the end of that 2. And then do divided by 0.06. If you don't close the parentheses at the end of the 2, you'll get a different answer, and it won't be the correct answer. So this is 11.55, a little over 11 and a half years.